Okay, in this presentation we are going to look at the Project Euler question 1. This is a series of problems that helps students of programming and mathematics develop their skills. We are using Jupyter notebooks and we are using Julia version 1.6.1, as you can tell up in the corner here. And we see the Jupyter logo there. This is intended for students of mathematical sciences, engineering, science, and so on, who are learning Julia and programming as part of their studies, let's say. So, anyway, let's look at this question here. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. Okay, the sum of these multiples is 23. Now the question is, find the sum of all multiples of 3 or 5 below 1000. Now just actually as a quick remark, it's below 1000, not less than or equal to 1000. So the last valid number there would be 999. Okay. So something that we're going to check here is something that we're going to use is the remainder operator there. So is 15 divisible by 3? The remainder, essentially, if we divide 15 by 3, the remainder would be 0. If we divide 15 by 4, we should get a remainder of 3. If we divide by 7, we should get a remainder of 1. Okay, 2 times 7 plus 1. So it gives us the remainder. That's it. Okay. Now, what I'm going to do here is set up a little function based on some numbers here. Okay. So I'm just going to test this to see if this number is divisible by 3. So essentially, this is my test for determining if a number is divisible by 3. Okay, in that case, it's going to be true. In this case, it's going to be false, and so on. Okay. So essentially, what we're going to do is compute the sum of the numbers, add them all up. And essentially, yeah, so let's go through this. The function here, we're going to create a function. And I'm just going to call it Euler 1 just because it's Project Euler question 1. And the input is n, okay, and the default for that, if we don't specify a value, is 10. Now again, just pick 10 because that's what we're given in the question. So what I'm going to do here is run a for loop and collect up the sum on an ongoing basis. So I initialize the total. I'm going to initialize this total here, total equals 0, and I'm going to run through all of the numbers between 1 and n. Now correctly, it's the last integer before n, so that's where that n minus 1 comes from. Okay, so it was less than n, so we're going from 1 to n minus 1. Okay, and if it is divisible, each iteration that we're looking at in this set of numbers, if it's divisible by 3 or if it's divisible by 5, okay, that's the OR function there, logical OR. Essentially what we'll do there is if the number is divisible by 3 or 5 or both, what we will do there is increment the total by that number. Okay, so it just collects up all of the relevant values and sums them up. So that's a straightforward enough idea, really. We're using for loops and if statements there and creating a function. Okay. Now, just actually, this is using very sort of straightforward concepts here, such as the for loop and the if statement. Okay. And that's actually a good thing because it's easy to understand, basically, and we can figure out what we're doing. Okay, let's just run that. So we have it created there in memory, and there we call it Euler 1. Okay, so let's run it for, I have it run here already. Let's run it for 1000. Okay, 233168. So that's really the number we're looking for there. Let's just test it for 100, just so you can cross-reference that. It's 2318. Okay. Now, something I'm going to do here is actually, I'm going to try out a different approach here. But what we want to do here is sort of the relative performance of each of the various approaches. So what I'm going to do here is actually see how much time this takes. Okay, let's run it again. There's a little bit of give or take in it, so it'll be between 2.7 and 2.9 e to the minus 6. That's actually usually quite fast, or I think that's pretty good. Okay, so we're interested in the speed of this approach, and remember we're using very simple things like for loops and if statements and so on. Let's try out a different approach. Now this is quite tricky. So this is a comprehension with an if-else construction. Okay, so we have this little test here. Okay, that's essentially a test, something like we have done before. Okay, and essentially if it passes the test, it will take this value. Okay, we'll keep this value, so it just keeps its value in this case. And if it fails the test, so to speak, it takes the value 0. So we're going to use this over the range of values from 1 to 10. Okay. And so the little question mark there is just part of the construction. So this is if, the if statement. This is just sort of part of the syntax. This is what happens if true, and this is what happens if false, basically. Okay. It's good to get the hang of these on an ongoing basis. This is not beginner stuff by any means, but they're not too bad, and it's good to get the hang of them. Okay, because you will see them around. So what happens to x equals 1 to 10? Well, essentially, for this particular test, if it's divisible by 2, if it's an even number, it keeps its value. Otherwise, 0. Okay, so we keep all the even numbers there, and all of the odd numbers get turned into 0. Okay, so we could do something similar to that here. So this is our test. Is it divisible by 3 or divisible by 5? Okay, and if it is, we keep the value, and if not, we turn it to 0. And again, 1 to 9 because below 10. Okay, so 003, 05, 6, 009. Okay, so essentially all we have to do there is sum them up, and that gives us 23. Okay, so this is the second approach here. Again, we're going to use this almost verbatim. What we're going to do there is set our default argument n equals 10, and just see here in the range n minus 1. X equals 1 to n minus 1, and then just output the total there. So this is version 2 of our program. Okay, and it should give the same answers, but you notice that's a bigger number than what we've seen previously, and that means I think it's a bit slower. Okay, so using if statements and for loops, that's quite efficient in terms of speed. And that's one of the sort of hallmarks of Julia. One of the characteristics of Julia is that for loops are very efficient. Okay, I won't go too much into that. I'm really focusing on beginner stuff, but it's good to get the hang of this stuff, good to be conscious of this stuff and develop a understanding of this stuff and the relative importance of it and so on. But really, going back to the start there, that was the key thing there. A straightforward function with if statements and a for loop and so on, and that done the job that we needed, and we're happy. Okay, we'll leave it there.